Okay, welcome back first years. Today's topic is something called the fundamental principle of counting, which seems like, gosh, we've gone through 13 or 14 years of our lives and we don't know how to count. It's not quite that. This is to do with outcomes when we have more than one event or more than one trial, okay? So we're going to write quite a complicated definition for this. And you do need to learn this. This is a definition that can be asked, so you need to learn this as if it's a science definition. Take it down into your notes copy using the same words that I've used, and you must learn it off. I'll do an example afterwards to explain what it means. So the fundamental principle of counting states that if you have two events, I really should say two trials based on the definitions that we had yesterday. So if we have two trials, not events, if we have two trials, the first with m possible outcomes, and the second with n possible outcomes, then the total possible outcomes for both trials is, and this is really important, m multiplied by n. So we really need to highlight that. I'm going to show you an example of what that means. So for example, if we roll two dice, two six-sided dice. If we roll two six-sided dice, then the total possible outcomes for the two dice, well, 6 for the first dice, 6 for the second dice. And we might think the total possible outcomes is 12. Instinctively, we tend to add them, but the fundamental principle of counting tells us we must multiply them. So the total possible outcomes for the two dice is 6 multiplied by 6, 36 different outcomes when we have two six-sided dice. Okay. What are the outcomes? Well, that's something else that we're going to learn soon. Let's do another example with the fundamental principle of counting first. So, first example is a menu example. So, for example, if Sarah is at a restaurant where the menu has 3 starter options, two main options, and 2 dessert options. And the question is, how many different three-course meals could Sarah order? Okay, well, the fundamental principle of counting tells us, so there are 3 outcomes for her starter, 2 outcomes for her main, and 2 outcomes for her dessert. If she was picking them at random, you can treat these just like probability. And the fundamental principle of counting tells us that we must multiply those options together, multiply the outcomes together. So the answer is, by the fundamental principle of counting, that she can order 3 times 2 times 2, which is 6 by 2, 12 different meals. Okay, that's what it tells us. It seems maybe a little bit surprising because instinctively, like I said, we tend to add them, but it's really important. So we must learn off that definition and learn how we use it as well. Now, you'll notice that I didn't write down what those options are. So, how do I display a sample space when I have 2 events? Let's look at this. So, sample spaces. Remembering from yesterday that our sample spaces are the list of our total possible outcome. So sample spaces for 2 or more trials. I keep saying events. When I told you yesterday that an event is something that happens, but a trial can give us more than one event. So sample spaces for 2 or more trials. And there's different ways that we're going to learn to do our sample spaces, but the first one we're going to look at today is called two-way tables. And I bet that you have seen these before, but you just haven't given them the name. So two-way tables are useful for when we have 2 trials. Let's look at an example. Okay, so in our example, Emma is trying to list the different meal combinations of drink and main and meal from the following options. For drinks, there's water, orange juice, or tea. And for the meal, she can choose pizza, nuggets, or a burger. Now, how many different meals could she make? Well, the fundamental principle of counting tells us that it will be 3 by 3, 9 different meals. And what we want to learn how to do is how will we list those out? Well, the first thing we're going to do is we're going to use letters to represent each of the possible outcomes. So instead of water, we'll use W. Instead of orange juice, we'll use O. And instead of T, we'll use the letter T. P for pizza, N for nuggets, and B for burger. And we're going to construct a two-way table. So let's see how the question might be asked like this. Construct a two-way table to show all different possible meals. Now, a two-way table looks just like a table in Word or Excel. What we have is we have a header across the top like this, where we put in one of the things. So what we're going to do is we're going to put our drinks going across the top. Let me just do the column going down as well first. I'm just going to use D for drinks, and I'm going to use each of my letters in turn. So I'll have water, orange juice, or tea going across the top, and my meal coming down here, pizza, nuggets, and burger. And then filling in the combination, I just put the two things together. Pizza with water, pizza with orange juice, or pizza with tea. So hopefully you can see the pizza is going in every option in its column. Nuggets with water, nuggets with orange juice, nuggets with tea. Nuggets in every single option here. A burger with water, a burger with orange juice, and a burger with tea. So tea is in all of its column, orange juice in all of its column, water in all of its column, burger in all of its row, nuggets in all of its row, pizza in all of its row. And that's how we construct a two-way table. And as you can see, there are our outcomes, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9 different combinations. So hopefully that's clear enough. I'd like you to practice a little bit with that, with the homework that I'm going to give you, which will be on page 131, question 6 and question 8, part A only. And of course, I'll be uploading a screenshot of that into Google Classroom as well. So thank you very much, and I will talk to you tomorrow.